Hello, I'm Jeff Fasho. I'm president and founder of Bialogics Analytics. Bialogics is a comprehensive, full suite of business and clinical intelligence applications, providing deep insights into the operational performance, productivity, and clinical analysis associated with your radiology department. Our fully interoperable and vendor-agnostic platform integrates the data created by both traditional risk pack systems, as well as third-party data like RVU tables, subspecialty data, physician scheduling information, natural language processing, and AI output. This allows us a unique advantage to create cross-functional data analysis for operational performance and productivity analysis, as well as clinical report analysis for quality assurance, research, and AI cohort development purposes. Our system is based on three separate modules: business intelligence, clinical intelligence, and AI performance monitoring. Allow me to introduce you to Bialogics DImax Radiology business intelligence platform by walking you through briefly these three modules.
I'd like to demonstrate now the three modules available within Biologics DImax system, starting with clinical intelligence. Clinical intelligence is our system that uses a very advanced natural language processing engine that processes every single radiology report that comes to us. And with that processing, we look for a number of things: clinical search tools, quality assurance tools, and most important, follow-up exam management. So if we do a clinical search on the database that we've selected here, we can go in and do a free text or a SNOMED concept search. So let me demonstrate very quickly by selecting a SNOMED concept search for the word pneumonia. So I can just type in the first few letters, pneumonia, SNOMED concept comes up. I click on that, so now it goes in, it searched the entire database that I have identified, and for SNOMED as a concept. So now I can actually say, okay, but I want to also include my sub-concepts so that I broaden the search capability out to make sure that I'm capturing all patients with pneumonia as a disorder, and also different ways of describing pneumonia as a disorder. So I get all my children or sub-concepts along with the primary concept. I can also select, do I want to see just patients that have presence in polarity present or polarity certainty? And then I can narrow that down even further to, do I want where pneumonia is found in the findings or the impression and in fact the semantic type. Now I can create further searches and multi-level searches to find very, very specific clinical criteria that meet the search for a particular disease entity, either for research or for the identification of a cohort for AI analysis. If I want to check on, as I look down my cohort list, I can go into any one of my studies and say, okay, this patient was selected as part of the cohort, and here's the actual report that was described by the radiologist in that particular case. So I can look at that particular report. I can also, using this little click, click into the actual viewer and actually pull up those studies so that I can actually view the study itself. Now, clinical search tools can become very, very multi-layered with a lot of search criteria to find very, very specific clinical criteria. And the processing of this only takes minutes, even though we've processed hundreds and thousands of studies in a short period of time. So this is very valuable for radiology research, or as I mentioned earlier, cohort identification for AI testing. So the second thing I want to demonstrate to you is our follow-up exam management. Follow-up exam management is important to provide a closed-loop system to managing all of your follow-up exams. So first off, we have our follow-up exam detector. So now every report that's coming to us, we're looking for the terminology within the report that identifies a follow-up exam is required. And in that identification, we look at what the procedure is. So for this case, what the procedure is requested. We have the radiologist report identifying the statement where a follow-up is required. We have the reason why there's a follow-up required, what type of procedure we'd like, and the timeline that is associated with it. Now I can again go into this report and also look at that patient's report and any subsequent follow-ups that already have occurred. Now, once we have identified this follow-up, it goes into our navigator system. So our navigator system provides the closed loop tool set that allows the navigator, instead of working off of spreadsheets and so on, to have a specific application and console to effectively manage those follow-up studies. So now the radiology navigator will say, okay, here's all the studies that are being assigned to me as follow-ups. Here's the report for this particular patient. Here's the report. So I can read the report and go, okay, yes, there's an imaging follow-up required. I've contacted the referring physician. I've scheduled that patient for the follow-up in the study that has been recommended. And indeed, we can get a notification at a later date that indeed the follow-up was completed without recommendation or with recommendation. So now this goes into the database. And so as I'm working as a navigator, I'm going to go through my day and I'm going to be able to identify what needs to be done, schedule those patients in an effort to take the follow-up exam from the typical industry 30 to 35% follow-up to a level of 65. So let's try in every effort to prevent those patients from falling through the cracks, not coming back at the reported time. Once we've categorized all of our patients for the course of the day, you can see here that this patient has been contacted, this patient has been scheduled, this patient in green has been, a follow-up has occurred, and so on. So now we're tracking every single patient that did require a follow-up over the time to make sure that we now don't lose those patients in terms of the follow-up and provide the patient care that's very much necessary. Third component of our clinical intelligence module is critical findings. What we do in critical findings is twofold. We first assess every radiology report to determine if there's a call log. So has a critical finding been identified as a call log, and has that call log been reported? The second thing we do is we do a complete analysis of every report for the terminology that the ACR uses to describe critical findings. So acute pulmonary emboli, ischemia, and so on. So not only are we looking and measuring not only are we looking for the reports that have been identified as a critical finding and that have been reported appropriately to the attending physician, but we're also providing the assurance by doing a secondary check to say, have any of our reports that we've completed had a term that is used by ACR to identify critical findings that we missed? And being able to provide that secondary check on all of those patients that may have been a critical finding. So this is one of the quality assurance. And in fact, in next release software, we'll also look at things like laterality, gender mismatch, and extremity mismatch as further quality assurance applications. So that's a little bit about clinical intelligence. Now in AI performance looks at the output of your AI algorithm by capturing the secondary capture or the DICOM overlay of the DICOM header and comparing that output to the clinical findings of the radiologist. And as a result of that, we're able to determine a number of real-time analysis and monitoring of your AI algorithm, starting with concordance and discordance, where we can do a search by, for example, by radiologists. We can look at by the actual AE title or the modality. So which AI algorithms are operating at better terms. So by looking at AE title, for example, we can compare different procedures, different protocols that are being used within one room to the next. By radiologists, we look at how many studies that this particular radiologist performed in conjunction with the AI algorithm, how many were concordant, so how many agreed between both the radiologist's findings and the AI findings, and how many, in fact, were discorded. And we can break that down. So now if we want to go in and say, as a follow-up to this, we can go in and we can look at each one of those studies to determine why it was either concordant or discordant. And you can see how we do that as well as the percentage of each of that patient. Second of all, we can do the same thing with sensitivity and specificity. In sensitivity and specificity, we're looking at the polarity of each study and measuring that based on the false positive, true positives, false negatives, true negatives, and so on. So again, we can look at that from an AE title perspective, and we can look at it from a radiologist perspective, and so on, to give our positive predictive values or negative predictive values. And again, we can determine the sensitivity and specificity. So this is kind of the raw data. Now we want to be able to import all of the data from clinical intelligence and our AI performance back into our business intelligence to show you how all of this data comes together in a very cross-functional analysis. The last module I want to briefly demonstrate for you today is our business intelligence, where we combine all of the data that we've collected from looking at our traditional risk packs, RVU, subspecialty analysis that's contained within business intelligence with clinical intelligence and, in fact, the AI performance. We're able to create user configurable dashboards that allow you as a user to create your own dashboards, your own landing pages, to look at the data the way you want to. So examples of this type of data are seen here. For imaging center utilization, for example, we go into performance monitoring for turnaround times by category, by all sorts of different analysis. We look at radiology productivity, so we can look at things like RVU. We can look at things like RVU production by radiologists. We can actually create, in many of our cases, our customers have created their own dashboards. So each radiologist has its own dashboard so that he can go in as his landing page and see where he's operating in terms of RVU production and studies that are being completed on a particular day or week. We also break it down to look at productivity by subspecialty, by integrating QGenda physician scheduling. So now we can look at the number of studies completed or RVU generation per session or per slot time within the course of the day. We also look at predictive forecasting now. Predictive forecasting is we're able to say, what did you do? If we want to look at a forecast, we say, well, how many studies were completed this month? Let's go back a year to the month that was a year ago, and now let's predict what that forecast will look like into the future. So providing forecasting based on any type of variable allows you to predict into the future so that you can plan your resources and growth appropriately. We look at, again, a summary of critical findings, looking at how many calls were logged in by subspecialty, by modality, by radiologist, and the actual reports that had critical finding identified but were not reported. We also look at the same thing with follow-up exams, that we track our follow-up exams, how many have been completed, how many have been created, how many have been completed, and the actual ones that are open as well. And then lastly, I just want to show you the AI performance reports. So AI performance reports, for example, here's our summary looking at 3 AI algorithms that we're using here in our demo system. And we look at for concordance and discordance based on gender and age, for example. If I want to go into one AI algorithm report, I can then go look at and say, okay, here's a detailed analysis of my concordance and discordance based on body part. So I can see the actual cohort of patients. I can see that the procedure description was a lumbar spine, in this case, number of exams. The AI algorithm determined that there was a fracture with an AI confidence rating of 98. And the radiologist also agreed that there was a fracture, so the AI and this study was determined to be concordant. And in fact, the actual terminology that the radiologists use to describe that fracture. Again, further detailed analysis of the concordance and discordance allows us to look at the modalities, the procedures, the age, the gender, and a number of other analysis. On top of that, we look at the drift reporting. So we now look over time, is our concordance and discordance um, creating a larger degree of accuracy bias, or is in fact staying as according to what the vendor has said that their accuracy will remain. Same thing goes with looking at, uh, same thing, fracture for AI fracture for sensitivity and specificity. We do the deeper analysis of that. But most importantly, now we take the information from our, our AI performance, our clinical analysis, and our business intelligence to look at productivity. And so we're able to look at the productivity before and after AI implementation. So looking at, for example, read times or turnaround times by radiologists, either with or without AI, as to show that is the AI algorithm actually meeting its accuracy rate that has been identified by the vendor, but also the impact on the department. How fast is it improving the workflow of your radiologists? So again, that's a little bit about how we take the three modules, blend that data in together to create cross-functional analysis that allows you, the user, to create the type of dashboards that are specific to your role or interest in the hospital, and allow this to be the core of how we integrate all of this data together to perform or to really identify biologics as a leading comprehensive business intelligence and clinical intelligence application. Thank you for your time.